So today we're going to look at a topic called implicit differentiation. Okay, now before we start this, let's just have a little look at what we mean when we say the word implicit. Okay, so we've been working so far with functions that are called explicit functions. And all that means is we could write it as y equals some sort of function of x. So say for example, if we had y equals x cubed, the graph would look like this. And obviously if I wanted to differentiate this, I would just write, well, if y equals x cubed, then we could say dy by dx would equal 3x squared. And then I could use this to tell me about the gradient for this curve. Okay, but not all functions are going to be explicit functions. So we're going to look at some functions that are called implicit. And essentially what we mean when we say this is we wouldn't typically write it as y equals a function of x. It would just be a function with x's and y's in. And we still need to know how to differentiate these functions. Okay, now you might think, well, why don't we just rearrange it to write it as y equals? And sometimes you can do that. But a lot of the functions that we're going to look at, you actually wouldn't even be able to write it as y equals if you wanted to. Okay, so we're going to look at a new technique which allows us to differentiate functions like this. So if we had x squared plus y squared equals 9, we definitely wouldn't start by writing dy by dx equals, because we didn't start with y equals, so we're not going to write dy by dx equals, are we? Okay, so if you look on the right hand slide, don't forget this notation, we've seen it before, haven't we? So if I want to differentiate with respect to x cubed, then the answer is just 3x squared. Nothing new there. That's not implicit. It's just differentiate x cubed with respect to x, which is fine. Okay, but if I was going to differentiate this function here, we'd have to be really careful with this y squared. Okay, because what we're now doing is implicit differentiation. We're differentiating a function of y with respect to x. Okay, now I'm going to show you sort of the way that I think about how this works, and then after that we'll do a quick shortcut. But I think if you can understand sort of the bit behind how it works, it will help us with some of the more complicated questions. Okay, so this derivative we can treat a bit like a fraction, and if I was trying to differentiate with respect to x, y squared, I can't do that. Okay, so instead we need to look at this and say, well, if I wanted to differentiate y squared, I would have to differentiate that with respect to y. So I'm going to introduce a derivative of y. Now that dx, we haven't done anything with that, so that's not going anywhere. So let's leave the dx on the bottom. And just think about how fractions balance out. Like if that dx was an instruction that we couldn't use, so it stayed there, we know we want to differentiate this with respect to y. To balance out what I've just included here, we can also include a dy on the top. So derivative with respect to y multiplied by dy by dx is the same as this original question that we're being asked about. And now that we've written it this way, all we have to do is say, well, I've got dy by dx. And now this is an instruction which I can follow. It says differentiate y squared with respect to y. So if I differentiate y squared with respect to y, I would get 2y. And these two things are just being multiplied together. Okay, so in summary, if you want to differentiate y squared with respect to x, your answer would be 2y dy by dx. Just pause for a minute and see if you can think about like what a shortcut might be in terms of missing out this little step with the derivatives here. Okay, let's try another one, and then maybe we'll try and get the shortcut if you couldn't spot it then. So if I was to differentiate with respect to x sine of y, that dx is something that I can't use. I can't differentiate with respect to x because it's a function of y. So I would differentiate with respect to y, sine of y, and to balance this out, I would include the dy here. So then I'm going to be left with dy by dx multiplied by the derivative of sine, and don't forget sine just differentiates to cos. And because we're differentiating with respect to y, sine y would just become cos of y. Okay, we don't need to multiply by anything at the front. The coefficient is 1, so you would be multiplying by 1 at the front if you wanted to. Think you've got the shortcut? So look, differentiate y squared, we get 2y dy by dx. Differentiate sine, we get cos y dy by dx.